calculating acceleration and displacement in the velocity time graph. Let's take this graph here. It is a graph of increasing velocity and acceleration is constant because velocity is increasing in equal interval time, equal in equal moments. Let's take these 2 points A and B. This is the point A, this is the point B. Now extend this line, this is at C. We have this velocity and this velocity. This is 5 is our initial velocity is U and 10 is our final velocity V. Now here 10 is T1 and 20 is T2. So our acceleration is V minus U upon T2 minus T. V minus U, this V minus U is our BC. And T2 minus T1 is our CA. This is our slope of the graph. So we can calculate here 10 minus 5 upon 20 minus 10. This is our 5 upon 10, 0.5 meter per second square. Our object is accelerating at the speed of 0, at the rate of 0.5 meter per second square in this velocity time graph, and our we can calculate the acceleration through this method. Okay, and acceleration is 0.5 meter per second square and slope of the graph is BC upon CA, which represent the acceleration of the object from point A to point B. Now how can you determine the displacement of an object? Displacement of object is here at A, this is at B. We are taking two instances at 5 and 10. So our displacement is this. It is a trapezium. It is a trapezium. As you realize, it is a trapezium. A. Let's talk it at. Let's take these points. ED. मैं आपके बुक के पॉइंट्स ले रही हूँ ताकि आपको कंफ्यूजन हो व्हेन यू स्टडी फ्रॉम द बुक. E and D. A, B, D, E, our trapezium. A, B, D, E. It is the displacement of an object. The area covered by this trapezium. Now we have two parts. This is the triangle and this is the rectangle. तो दोनों का एरिया लेंगे. Area of ABC plus area of ACDA. Okay, this is half BC upon CA, BC into CA plus area of triangle is CD upon CD into AD, CD into AD. BC, our BC is 10 minus 5, that is 5. CA is 20 minus 10, that is 10. CD is our CD is 0 to 5, that is 5. And ED is again 10. 25 plus 50. Our area is 75 meters. Our area is 75 meters. I have taken the same marking as it is given in your book. So that is how we can calculate the displacement when the velocity is increasing and acceleration is constant. Now, how can you, when an object is moving at a constant velocity, that is acceleration is 0, can you find the displacement? Yes, we can also find the displacement by this. Let's take an example where the object is at constant velocity. 5 6. Time is also always on the x-axis. Okay, and this is 5, 10, 15, 20, 25. The object is moving and it reaches at 6. So we have this is position A and this is position B and this is O and this is C. So our displacement will be represented by this area of the rectangle. The area of rectangle, what is the name of the rectangle? It is ABCO. ABCO. This is BC into OC. BC into OC. Now, BC is 0 to 20, that is 20, and OC is 6. 0 to 6. That is velocity. That is, it is velocity into time. That is its displacement. This is why it is called the displacement. The 20 into 6, 120 meters. So we have displacement of object 120 meter. Now let's take example of the object. We have decreasing velocity, यानी कि velocity is decreasing and acceleration is in the opposite direction of the velocity. Let's take this graph. And how can you calculate the acceleration from this graph? First, take example. Again, same graph आएगा जैसे हम पिछले previous video में था हमारा. We have मैं markings अब इतने नहीं कर रही हूँ. 15. We are at 15 here. We have at 30. Yeah, we have straight line here. 2 points are A. A point is as 10. And another point is B. It is at 5. B is at 5. Here B is at 20. And here A is at 10. And this is our point C. And this is our point O. This is our point O. Up here, this is my initial velocity. 15 is my initial velocity. Sorry, it's not 15, sorry, it is 10. 10 is our initial velocity. And here, our final velocity is at 5. 5 is our final velocity. This is B minus U. B minus U upon T2 minus T3. Our acceleration is our B minus U. And B minus U here is 5 minus 10 T2. This is T1, this is T2. This is T2 minus T1, that is 20 minus 10. It is equal to minus 5 upon 10 minus 0.5 meters per second square. This is how we can calculate the velocity. And we can calculate the acceleration from the velocity time graph when velocity is decreasing. So in this video, we have calculated the acceleration when velocity is increasing. We have calculated the displacement when velocity is increases. We have calculated the displacement also when velocity is constant, that is acceleration is 0. And we have calculated the acceleration when velocity is decreasing. We can also calculate the displacement in this. This is the area where it is the displacement of the object from this area. We can calculate similarly in the previous graph as we have calculated in the previous graph.